Alright, now we're going to look at a shortcut that we can use when the trinomial that we are factoring is actually a perfect square trinomial. So the way that we can determine if it is a perfect square trinomial is we need to look at the first term and the last term. And both of those terms have to be a perfect square trinomial. Or they have to both be a perfect square. So m squared is a perfect square. 64 is a perfect square. So what I'm going to do is I'm going to go ahead and write my parentheses. I'm going to take the square root of m squared, which is going to be m. And I'm going to take the square root of 64, which is going to be positive 8. Now for me to check to see if this is actually a perfect square trinomial, I'm going to take 8 times m, and I'm going to get 8m, and then I'm going to double that, which gives me 16m, and that happens to be my middle term. So that tells me that this is a perfect square trinomial. So my answer is going to be m plus 8, and that's squared. So that would be my answer. Now remember, that means m plus 8 times m plus 8 if you wanted to box it to check it. So now we're going to check to see if this is a perfect square trinomial. So we're going to look at the first term, and we're going to look at the last term, and we're going to see if those two terms are perfect squares. So 16 is a perfect square, and p squared is a perfect square, so that works. And 9 is a perfect square, so we're going to take the square root of 16, which is 4, and p squared, which is p, and the square root of 9, which is 3. So now I have to check to see if this squared will give me my trinomial. So I take this term and I multiply them, and I get 12p, and then I'm going to double it, which is 24p. And you'll notice that the 24p is also the middle term, which means I've found the factored version. It's 4p plus 3 is equal to 2. Alright, so now we're going to take a look at the, again, first term and last term. So 4 is a perfect square, y squared is a perfect square, 25 is a perfect square. So we'll go ahead and put our parentheses in. We're going to take the square root of 4, which is 2, the square root of y squared, which is y, and we're going to take the square root of 25. Now because this middle term is negative, we're going to take the square root of 25, which would be negative 5. Now we're going to see if this squared creates the trinomial. So we're going to do 5 times 2y, which is going to give us negative 10y, and we're going to square it, which gives us negative 20y. So that is the answer. So it'll be 2y minus 5 squared is the factored version of that trinomial. Alright, let's take another one. 36b squared, perfect square. 25, perfect square. Now notice I have a negative, which means I'm going to use the negative root of 25. So I'm going to go ahead and put my parentheses. The square root of 36 is 6. The square root of b squared is b. The square root of 25 can be positive 5 or negative 5. Since my middle term is negative, I'm going to need to take that negative root. And now I'm going to check to see if this is the factored version. So negative 5 times 6b gives me negative 30b. And when I double that, it gives me negative 60b. So that means this is not a perfect square trinomial, which means this is not going to be the answer. I would have to bounce it in order to factor it. And the last one we're going to do, a squared equals pi squared. So in order to factor that, we would do, first we need a zero pair because it has to equal 0 in order to factor. So we would subtract the pi squared. So it'd be a squared minus pi squared. Now this is not a trinomial, but I do have two terms, so I can see if it's the difference of two squared. So a squared would be perfect square. Pi squared would be perfect square. Subtraction, so I do a quick plus and minus. The square root of a squared is a, and the square root of pi squared is pi. And that would be my factored version.